potential introduction of a bill to ban incandescent bulbs raises questions about freedom of choice and government regulation. Many believe that individuals should have the autonomy to select the light bulbs they prefer for their homes and businesses. A legislative mandate dictating permissible light bulb types may be perceived as an overextension of governmental power. An alternative approach involves educating the public about the advantages of adopting energy-efficient lighting solutions. Providing individuals with comprehensive information empowers them to make informed decisions regarding their lighting preferences. Stocking up on -19 incandescent bulbs might be a practical measure in anticipation of potential restrictions. However, the bill's ultimate fate remains uncertain. The core issue revolves around balancing individual liberty with broader environmental concerns. Incandescent bulbs, while familiar and often preferred for their warm light, are less energy efficient compared to alternatives like compact fluorescent lamps, often referred to as CFL, and light-emitting diodes, known as LED. CFL consumes significantly less energy than incandescent bulbs, typically around 75% less, and have a much longer lifespan. LED are even more efficient, consuming up to 80% less energy and lasting considerably longer. The lifespan of an incandescent bulb is typically around 1,000 hours, while CFL can last up to 10,000 hours, and LED can last 25,000 hours or more. This extended lifespan translates to fewer replacements and reduced maintenance costs over time. The energy savings associated with CFL and LED contribute to lower electricity bills for consumers and a reduced demand on power grids. From an environmental perspective, decreased energy consumption leads to reduced greenhouse gas emissions from power plants. However, concerns have been raised regarding the mercury content in CFL, which necessitates proper disposal to prevent environmental contamination. LED do not contain mercury, making them a more environmentally friendly option in this regard. The Color Rendering Index, or CRI, is another factor to consider when choosing light bulbs. CRI measures how accurately a light source renders the colors of objects compared to natural sunlight. Incandescent bulbs generally have a high CRI, typically around 100, meaning they render colors very accurately. CFL and LED have improved significantly in terms of CRI, and many models now offer CRI values comparable to incandescent bulbs. The correlated color temperature, or CCT, describes the color appearance of the light emitted by a bulb, measured in Kelvin. Lower CCT values, such as 2700 Kelvin, produce a warm, yellowish light, similar to that of incandescent bulbs. Higher CCT values, such as 5000 Kelvin or 6500 Kelvin, produce a cooler, bluer light, resembling daylight. Consumers can choose bulbs with CCT values that suit their preferences and the specific lighting needs of different rooms. The initial cost of CFL and LED is typically higher than that of incandescent bulbs, but the long-term cost savings due to reduced energy consumption and longer lifespan often outweigh the initial investment. Government incentives and rebates are sometimes available to encourage the adoption of energy-efficient lighting technologies. The dimming capability of light bulbs is another important consideration. Incandescent bulbs can be easily dimmed using standard dimmers. Some CFL and LED are dimmable, but it is essential to ensure compatibility between the bulb and the dimmer switch to avoid flickering or other issues. The shape and size of light bulbs can also influence the choice. Incandescent bulbs are available in a wide variety of shapes and sizes, including -19, which is a common household bulb shape. CFL and LED are also available in various shapes and sizes, but it is essential to choose a bulb that fits the intended fixture properly. The light output of a bulb is measured in lumens. A higher lumen value indicates a brighter light. When replacing incandescent bulbs with CFL or LED, it is important to choose a bulb with a comparable lumen output to achieve the desired level of brightness. The directionality of light is another factor to consider. Incandescent bulbs emit light in all directions, while some CFL and LED may emit light in a more focused direction. The choice depends on the specific lighting application. For general illumination, an omnidirectional bulb is often preferred, while for task lighting, a directional bulb may be more suitable. The warm-up time of a bulb is the time it takes to reach its full brightness. Incandescent bulbs reach full brightness almost instantly, while some CFL may take a few seconds to warm up. LED typically reach full brightness very quickly. The noise level of a bulb can also be a consideration. Some CFL may produce a slight buzzing sound, while incandescent bulbs and LED are generally silent. The safety of light bulbs is an important factor. Incandescent bulbs can get very hot, posing a burn risk. CFL and LED generate less heat, making them safer to handle. The environmental impact of light bulb production and disposal should also be considered. Incandescent bulbs are relatively simple to manufacture, but their short lifespan results in frequent replacements. CFL contain mercury, which requires careful handling and disposal. LED have a longer lifespan and do not contain mercury, making them a more environmentally friendly option overall. The availability of different types of light bulbs can also influence the choice. Incandescent bulbs are widely available, but their future availability may be limited due to energy efficiency regulations. CFL and LED are becoming increasingly available as their popularity grows. Price of light bulbs is another important consideration. Incandescent bulbs are typically the least expensive option, but their higher energy consumption and shorter lifespan can make them more expensive in the long run. CFL and LED have a higher initial cost, but their lower energy consumption and longer lifespan can result in significant cost savings over time. The ease of installation of light bulbs is also a factor. Incandescent bulbs, CFLs, and LED are generally easy to install, but it is important to follow the manufacturer's instructions carefully. The compatibility of light bulbs with existing fixtures is another consideration. Most CFL and LED are designed to be compatible with standard light bulb sockets, but it is always a good idea to check compatibility before purchasing. The warranty offered on light bulbs can provide peace of mind. Incandescent bulbs typically have a short warranty, while CFL and LED often have longer warranties. The energy efficiency rating of light bulbs is an important indicator of their energy performance. Energy Star certified bulbs meet strict energy efficiency guidelines and are a good choice for consumers who want to save energy and money. The light distribution pattern of light bulbs can also influence the choice. Incandescent bulbs emit light in all directions, while some CFL and LED may emit light in a more focused direction. The choice depends on the specific lighting application. The color rendering capability of light bulbs is an important factor for tasks that require accurate color perception. Incandescent bulbs generally have a high CRI, making them a good choice for these applications. The operating temperature range of light bulbs is another consideration. Some CFL may not perform well in cold temperatures, while incandescent bulbs and LED are generally less sensitive to temperature. The humidity resistance of light bulbs can also be a factor in certain environments. Incandescent bulbs are generally resistant to humidity, while some CFL and LED may be more susceptible to damage from moisture. The vibration resistance of light bulbs is another consideration for applications where the bulbs may be subjected to vibration. Incandescent bulbs are generally less resistant to vibration than CFL and LED. The impact resistance of light bulbs can also be a factor in certain environments. Incandescent bulbs are generally more fragile than CFL and LED. The electromagnetic compatibility, or IMC, of light bulbs is another consideration. Some CFL may emit electromagnetic interference, which can affect the performance of other electronic devices. LED generally have good EMC performance. The electrostatic discharge sensitivity, or ES, of light bulbs is another factor. Some LED may be sensitive to ESD, which can damage the bulb. The surge protection capability of light bulbs is another consideration. Some CFL and LED may be damaged by power surges. The power factor of light bulbs is a measure of how efficiently the bulb uses electrical power. A higher power factor indicates better efficiency. LED typically have a higher power factor than CFL. The total harmonic distortion, or THD, of light bulbs is a measure of the distortion of the electrical waveform caused by the bulb. A lower THD indicates better performance. LED typically have a lower THD than CFL. The luminous efficacy of light bulbs is a measure of how efficiently the bulb converts electrical power into light. It is measured in lumens per watt. LED typically have a higher luminous efficacy than CFL and incandescent bulbs. The correlated color temperature, or CCT, is the specification of the color appearance of the light produced by a light bulb. CCT is measured in Kelvin. A lower CCT corresponds to warmer, more yellow light, while a higher CCT corresponds to a cooler, more blue light. The color rendering index, or CRI, is a measure of how accurately a light bulb renders colors compared to a reference light source, such as sunlight. CRI is measured on a scale of 0 to 100, with 100 being the highest possible score. The light output of a light bulb is the total amount of light emitted by the bulb, measured in lumens. The power consumption of a light bulb is the amount of electrical power the bulb uses, measured in watts. The voltage rating of a light bulb is the voltage at which the bulb is designed to operate. The current rating of a light bulb is the current a bulb draws when operating at its rated voltage. The frequency rating of a light bulb is the frequency of the alternating current, or AC, power supply the bulb is designed to operate on. In most countries, the standard frequency is 50 Hz or 60 Hz. The operating temperature range of a light bulb is the range of temperatures within which the bulb is designed to operate. The storage temperature range of a light bulb is the range of temperatures within which the bulb can be stored without being damaged. The humidity rating of a light bulb is the maximum humidity level the bulb can withstand without being damaged. The ingress protection rating, or IP rating, of a light bulb is a measure of the bulb's resistance to dust and water. The lifespan of a light bulb is the average amount of time the bulb is expected to last before burning out. The warranty period of a light bulb is the length of time the manufacturer guarantees the bulb against defect. The certifications of a light bulb are the standards the bulb has been tested and certified to meet. The safety precautions for using light bulbs are the measures that should be taken to prevent injury or damage when using light bulbs. These precautions include using the correct voltage, wattage, and bulb type for the fixture, and avoiding touching the bulb when it is hot. The disposal methods for light bulbs are the proper ways to dispose of burnt-out light bulbs. Some light bulbs, such as CFL, contain hazardous materials and should be disposed of properly to prevent environmental contamination. The recycling options for light bulbs are the ways to recycle burned-out light bulbs. Some light bulbs can be recycled to recover valuable materials.